You're floating in space, 100 kilometers from a black hole, close enough to see it warp the stars behind it into a swirling ring of light. And then your thruster fails. You start falling. What you're about to experience is the strangest, most mind-bending journey in all of physics. You won't just die. You'll be stretched, frozen in time, and possibly duplicated all at once. A black hole is what happens when a massive star, at least 25 times the mass of our Sun, runs out of fuel and collapses. The star's core crushes down into a point of infinite density called a singularity. The gravity is so extreme that nothing, not even light, can escape once it crosses a boundary called the event horizon. The smallest black holes are about 3 times the mass of our Sun, squeezed into a space smaller than a city. The largest, supermassive black holes at the centers of galaxies can be billions of times the Sun's mass. The one at the center of our Milky Way, Sagittarius A star, is 4 million solar masses. But here's the key thing. A black hole isn't a hole. It's not a portal. It's an object, an impossibly dense, impossibly powerful object that warps space and time so severely that the normal rules of physics break down. Okay? Your thruster has failed. You're falling toward a stellar black hole, about 10 solar masses. As you approach, the first thing you notice is that the stars start moving. The black hole's gravity bends light from behind it, creating a distorted halo. Stars that should be behind the black hole appear to slide around its edges. As you get closer, something bizarre happens. Time itself starts to slow down. For you. From your perspective, everything feels normal. You're falling, picking up speed. But if your crewmate is watching from a safe distance through a telescope, they see something completely different. From their perspective, you appear to slow down. Your radio transmissions stretch out. Your voice drops to a deep, slow rumble. Your body appears to turn red, then infrared, as the light you emit gets stretched by gravity. This is called gravitational redshift. Eventually, to your crewmate, you appear to freeze completely at the event horizon, just stuck there, fading, getting dimmer and redder until you disappear entirely. From their perspective, you never actually cross the event horizon. You fade away at the boundary forever. But from your perspective, you don't notice anything special when you cross the event horizon. There's no wall, no barrier, no sign that says point of no return. Space and time have been so warped that falling inward is now the only possible direction. Every path, even if you turn around and fire your engines at full blast, leads deeper in. Looking back up, you'd see the entire universe compressed into a shrinking circle of light above you. All the light that can reach you is funneling in through that narrowing window. It's like looking up from the bottom of an increasingly deep well. And now comes the part that kills you. Spaghettification. The gravity at your feet is significantly stronger than the gravity at your head. This difference, called tidal force, stretches you vertically and compresses you horizontally. Your body starts to elongate. For a stellar mass black hole, this stretching becomes lethal well before you reach the singularity. Your body would be pulled into a thin strand of atoms, like a piece of spaghetti, hence the name. Every atom in your body is ripped apart and drawn into a thin stream spiraling inward. Interestingly, if you fell into a supermassive black hole instead, like the one at the center of our galaxy, you could actually cross the event horizon comfortably. The tidal forces at the event horizon of a supermassive black hole are surprisingly gentle because the event horizon is so far from the singularity. You wouldn't be spaghettified until much later, deep inside. Some physicists have even suggested that a sufficiently large black hole could contain entire solar systems inside its event horizon. Spaces where physics works almost normally, where you could orbit, drift, maybe even survive for a while, before the singularity eventually claims you. At the center of every black hole lies the singularity, a point where density is infinite, and the known laws of physics simply stop working. General relativity breaks down. Quantum mechanics breaks down. We genuinely don't know what happens there. Some theories suggest the singularity might be a gateway, not to another place in our universe, but to an entirely different one. Others suggest it's where information is destroyed, violating one of the most fundamental rules of quantum physics. This is called the black hole information paradox, and it's one of the biggest unsolved problems in all of physics. Stephen Hawking showed that black holes slowly evaporate over incredibly long timescales through a process called Hawking radiation. A stellar black hole would take 10 to the 67th power years to evaporate. That's a number so large it makes the current age of the universe, 13.8 billion years, look like a rounding error. Black holes are the most extreme objects in the universe. They break time, bend space, and challenge everything we think we know about reality. And there are billions of them in our galaxy alone. The nearest known one is just 1,600 light-years away. Close enough that if black holes had a sense of humor, we'd be the punchline. If this blew your mind, subscribe to THEORETIKA. Next time, what's actually hiding at the bottom of the ocean?